current demands of the customers. And there are some machine learning models we can use to train our data or the machine, and that can be a beneficial to generate the forecast. So there are a couple of most popular models which we are using. That is one is the random forecast. It's an essential learning method that builds multiple decision trees and average their prediction for a regression or majority voting for classification. The key advantage or the strength of this is it's easy to use, handle non-linears and non-linearity well, but it's very slow for the large data set, and it's not very much interpretable, and maybe not so time time dependency. This no model doesn't have a time dependency. The second model is the XGBoost. It's an optimized gradient boosting algorithm that build tree sequentially and minimize losses with regulating the better performance. And it has high accuracy, fast and efficient compared to the random forecast, and handle missing data and outlier, and then complex tuning. The If you want to tune the model, it's bit complex. And the third one is the LSTM network. That is um, a special type of recurrent neural network capable of learning long-term dependency in the sequential data. Use the memory cells and design the time series data and capture temporal dynamics, handles long sequence ca- computability expense, and it's a bit expensive because it required lots of memory and chips. And require to train this model, we need a large data set, and it's really hard to interoperate. So now as we see that the agenda is the going with one model, giving us one solution for all the problem will not be an ideal situation. So the companies are realizing that going with the hybrid model will be the go-to solution for the industry, where um, it integrate multiple forecasting methods like ARIMA and neural network to improve prediction accuracy by capturing both linear and non-linear pattern in data. So why use hybrid model? So one is a statistical foundation. It captures linear trend and seasonality pattern. Like let's say it seasonality and journal. We can add journal also. Like somewhere it's very hot, so then the sales of the winter clothes will not that much compared to the summer clothes. The It optimize the prediction, so it will deliver more accurate forecast than single method approach, because it looks for when it analyze the data, it look for the appropriate machine learning model, and apply that model which handle linear non-linear data and the seasonality, and uh, the the prediction or the forecast for the machine will be optimized compared to the other models, the non-hybrid models. And the machine learning is uh, enhanced because it addresses non-linear relationship and complex pattern between the data. So it has a more trained machine learning model than the single. or any single model. And it combined the processing, the process output through example of residual learning technique. So this is one of the important thing that other residual learning is not possible in a single model. So that fill the gap and it make it robust and flexible to generate more accurate forecasts. Um, there are some hybrid type, and then the examples, and then what is the purpose. So is first is a statistical plus machine ML. It's a combination of ARIMA plus ANN, neural network, or ARIMA plus LSTM. It captured the trend through ARIMA and residual pattern through machine learning, ML. The another one is the ML and ML. ML is it can be XGBoost plus LSTM, the neural network one. It leverage boosting and deep sequential modeling. So the deep learning can need to be done to understand some non-linear data and the seasonality. So this model, this hybrid model is really beneficial. And then the another one is composition, STL decomposition plus XGBoost. It decomposes the series into trend, seasonality. So basically, to how we train the model, we take the sales history of the previous years. It can be based on the depend on the company's sector and the model they work. But usually company take the 5 years of sales history, and then they put it into these models, and then it it time series data like monthly, weekly, quarterly, and then hierarchy, location based, uh, location based, customer base, and that based on that it identify the trend and the season, and if there's any noise means it can be a outlier, and then identify and then train the machine and then generate the forecast. And then the next one is the ensemble averaging or stacking. It can be a random forecast plus LSTM or SVR. It combines the prediction from multiple models and then average it out and then show it. So there are some cases ready, one for the clearance of sale. Uh, the purpose of this study is focus on forecasting demand for market down pricing in a situation where historical data are limited, and propose the purpose of using hybrid knowledge base residual that we call KLR, KRL network to enhance the accuracy of demand prediction in the fast fashion retailing outlets. So this research has been done by this gentleman Weekend in 2025 on the residual learning of sales forecasting, and the methodology they use, research methodology they used hybrid KRL network structure to increase the forecast accuracy in fast fashion data by combining the artificial neural network and theoretical demand models, what we call ANN plus TDM, such as nonlinear exponential multinomial logic, and then they use the linear demand model, that what we call LDM, as a theoretical demand model. So it was this theory to experiment how it works, and then which is one of the um, popular TDM in the literature, and combine it with the neural network by utilizing the residual network structure. And then they tested in the real fast fashion data to estimate the next week's demand for the for the clearance season. So basically, they created it by using this um, algorithm, created a model, and then that initially it was based on the theory and literature, but they apply it in a real life situation for one of the company and see how the clearance sales is going on and how much demand is. And then the finding was very interesting. The result underscored the KRL capability to derive mutual benefit from both neural network and LDM, the linear data demand model, and especially in the specific context of where we have a limited fast fashion sales data, and uh, it outperformed the model of LDM and ANN individually in forecast accuracy. So the effectivity of the clearance sale with unpredictable customer behavior pattern. The second case study was done uh, for the one of these the one is the manufacturer and another company was the retailer that manufactured the substitute product. So, so we have examined the supply chain contrast for two competing supply chain selling a substitute product. Each consists of one of the manufacturing and one is the retailer, and both both manufacturer are Steakburg leader and the retailer are the followers. So manufacturing into competing supply chain may choose different contracts, either a wholesale price or contract in which the retailer demand forecasting the information. That data we didn't get, but the revenue sharing contract in the which the retailer demand forecasting information is shared. Under the supply chain competition and demand uncertainty, what they have identified that contract is more advantageous than for each supply chain and under what circumstances. So they also apply the hybrid model that combine the ARIMA with machine learning and increasingly deployed the address the non-linear and seasonal complexity in the demand forecasting within fast fashion. So these methods benefit from ARIMA's strength in the capturing linear temporal pattern, while machine learning ML layer like decision tree, neural network, and are used to model residual and non-linear trend. The the concrete and practical implementation of this hybrid stack is presented in this study, who conducted a real world case study by combining these two models, ARIMA and ML. So the basically they use neural network layer um, to enhance the efficiency of the forecasting, and that increase the 15 to 20% of improvement over on overall traditional forecast method. Um, so this is a one. So there are several ERP systems available widely used by the customer: Oracle, SAP, O9, Blue Yonder. So how do they predict the use their demand and how they do forecasting? Uh, they first we need to first feed the data that can be a qualitative data or quantitative data. The sorry quantitative data or qualitative data. Quantitative data can be a sales order, shipment, booking, shipping, returns, histories, and then what is the sales revenue for the seasonal items, etc. and then based on that we feed that, and then I work for Oracle, so Oracle use the Bayesian algorithm to to process these data and then finalize the forecast result. The another is qualitative data. So qualitative data may be some let's say someone is launching a new clothes, a new pattern design cloth, and then that is a very new product for the company, and then they want to gauge the demand. So the the company's marketing team market that product in a market. They do some research how what can be the demand based on the sentiment of the person, based on the advertisement they have done, social media advertisement, and then they get the sense that how much this product has been popular among the this segment, this geography, uh, uh, and of the people. And based on that research, the survey, they come up with some number. So that no, those numbers are really important because sometimes forecast model give a not that accurate number, but the market survey uh, also can be a game changer. So that qualitative data also important when system generated baseline forecasts need to be reviewed by the all the stakeholders. And these data can be feed to the machine, and then machine generate a baseline forecast or a statistical forecast, and then all the planners or demand planners come and review those data and come and take the input from all the stakeholder and come up with the finalized number. What will be our final forecast for for that new product? And based on that, once they feed that, put those numbers in a system, the planning demand forecasting engine will run and then generate the forecast. And then supply planning team, supply management team look for the available inventory, or if it's a uh, make item, then they look for the raw material, how much raw material we have in our manufacturing location or shop floor, and then they find out if how based on the demand how much raw material we needed. If there's a shortage of the raw material, they procured the raw material from their supplier, for that they release the purchase order to uh, procure the supply the material, and they add the lead time, supplier lead time on the total manufacturing time of the product. So this basically help to plan and manufacture if we have a if we are getting the accurate number of forecast number, and that basically reduce the um, inventory wastage, and help planners to plan in advance. Um, so there's something called digital twinning for the fast fashion. So digital twinning is a virtual replica of physical system, such as a product, process, or entire supply chain that mirror real world behavior using real-time data and simulate with the AI. It's a demonstrate concept, and it's widely used in the industry 4.0, and that enable company to test scenarios where they can predict the outcome and optimize the performance without physically altering any real system. So we can just simulation. We can run a simulation and see how the demand is getting how this when we change the data, how demand is forecasting is changing, uh, and what is our actual sales is going on, and then we can compare the accuracy of that forecasting model. Mm, okay, so that work explored the media of operational decision making in a fast fashion manufacturing of the company considered in Industry 4.0. The segment require agile and flexible decision-making technique to guarantee the company's survival in in a high volatile environment of the product and demand. The purpose of this approach was based on the three stage. And the first stage is we suggest change and improvement in the system to adopt it to the adoption, and then mm, uh, then real-time demand planning, where dynamic inventory, um, we adjust that, we change basically we will tune the parameter, and then see how it behaving, and then the final is the operational result. So uh, operational result is like uh, what our system has generated the forecast and what is the actual sales, and then identify the stock out or inventory cost um, in that case. The whether whether we are getting a stock out means the forecast is generated, the number of forecast is generated by system is lower than the actual sales happen in a real world, and mm, that reduce that that is basically that's not good for the company, because then the SLA or the SLA will increase for the company, and then it reduce the profitability of the company. Yeah, so this is the evaluation matrix which company use to see how their models are working, or it can be a rubrics for the organization or the company to evaluate the model's accuracy. So the first one is the RMSE, that is called root mean square error. It's penalizing large error. So um, when there's a very major error happen, blunder happen, then that we can track that error in this matrix. Second one is the mean accuracy error. That is the over it measure average magnitude of error in the set of prediction without considering their direction, and then interpret then the interpret the it what does this mean? That says lower MAE errors is more accurate the prediction. So the all models try to bring down this number so that accuracy can be increased. Another is one is the most famous is MAPI, mean absolute percentage error. It it is the it penalizes large error more than more than MAE due to squaring. It just square the number, and it good for detecting model that occasionally make larger error. The next one is this one more model that we called it RMS. Sorry, uh, yeah, RMS. Yeah, I cover SMAP. It's a symmetric mean absolute percentage error. It handle uh, zero near zero values. So just it if there's decimal values, so it just handle those values. Then last one is the time series CV. It cross-validate from time series like other weekly or monthly forecast and validate those data. And then this is a realistic model evaluation. So there are a couple of few more models which company use like R square, and that is a coefficient regression, that is for the regression model, that major proportion of variance in the dependent variable and predict from the independent variable. And the closer to one is better model. And there are some tools and technology which is widely used to design these models. The Python libraries we have with this, the scikit-learn, TensorFlow, and Prophet state models. And there's some cloud platform where we store the data, like most of the large companies are using these cloud platform to store the data and evaluate their model. At AWS forecasting, Azure has their machine learning, and then Google Cloud also have, and then Oracle has their OCI, OIC, and their visualization tools where we can visualize the forecast and trends using Tableau or Power BI. Yeah, yeah, so yeah, that's it. Any question and answer?
If Dalip, I don't have any questions. I did provide a question, but I'm gonna unmute the guests here and see if they have any questions by raising your hand. You can find that in. I can unmute you. Okay, there's a question, Dalip, from Lev Jen, and the question is, what is a typical workflow for preparing new forecasting model?
So workflow, what I can tell you based on my experience. Um, First of all, we need some historical data that can be a uh, sales order history, booking history, shipping, returns. Those data play a essential role. And then we need to see how company is operating, um, the hierarchy. We need to define the hierarchy. Um, it's location, like region, location, and then like country, state, city, store. That kind of hierarchy need to be defined, and then time series, like oh, how do we want to forecast, like monthly, weekly, uh, daily, or quarterly. So once that our hierarchy and levels define, uh, then we just start feeding the data into the machines, and then this create a machine learning models by using the uh, popular, we can try with for the first with linear data, where with flat sales history with over the period of 1 year, 2 year, 3 years, and then start training the model and see the see the accuracy, and we can define some few parameters that needs to be used to tune the models, and the models, the algorithm, the accuracy, we need to train the model by feeding the data and minimizing the errors like mean map error, mean square root errors, and other parameters. So this is a general flow. Now most of the ERP companies are giving that models inbuilt with their products. So we just need to design the hierarchy and the products and the level. Just we need to set up the model and then format the data into that the way they accept, and then load into the algorithm, and they will process and generate the forecast. Uh, uh, any other question, John?
I don't have any other questions. What I like to do is ask the audience,
Okay.
attendees, to answer the following questions. If there's interest in PDH hours, uh, please type 1 for yes and 0 equal no. The reason why I ask is that in order to receive PDH, the session has to be over 1 hour, and otherwise, this session will not qualify as a PDH. So, if you can type in the chat 0 or 1, then I can ask more questions to make this last an hour. Otherwise, we can close this session early, and then you guys can leave early. So so far, no feedback, Dilip. So I can ask one question that I
Okay.
have a particular interest. I'm not familiar with the acronyms that you mentioned in the slide. Um, basically, ARIMA and the other acronyms that you had on one of the slides, I think early. Can you
Okay.
just give a brief explanation of each and or what the acronyms stand for? And I
Okay.
mentioned in the chat that my last, since there's no, okay, I did get something, but just answer maybe what is a RIMA and AN. And there's a question afterwards. How much data is considered enough? Is it 1,000 rows or company needs more?
How much data consider? Sorry. Yeah.
How much data is considered enough? Is it 1,000 rows, thousands of rows, or does the company need more?
Can I read the question? Come to forecast the
Okay.
generate the forecast.
Yeah, and then LevGen answered it. It says enough for training a new model. So the
One more question, if possible. How much data is considered enough? It is
yeah, is
1,000.
it 1,000 rows or does a company need more data, more than 1,000
Um,
rows of data?
it depends. Uh, it depends. Like usually, on an average, it's recommended. Uh, it's not a thumb rule, but usually in my organization, I can. So we are publishing company, so we use 5 years of sales history of data. That like to cover the seasonality, non-linearity, and other stuff. The 5 year says of data average out other things. So um, depends the business of the organization. Like if we're just building educational or the literature model, then 1,000 should be fine. But for a company who works in a real time, they need as they need more data to train their model to see the accuracy of the forecast. So literally, we have millions of row for or the data when we load the data. It has 5 years of sales history, return history, booking, shipping, and that become more than 10 millions of record. So it depends like where we are in. If it's in industry or any company, high order industry, then it requires really the replica of the previous sales, what happened in the previous sales. So previous years. Okay. Thank you. So, so John, you ask what is the ARIMA,
Yeah,
and
RIMA and all the acronyms that you listed in one of the slide. Just
okay,
maybe because of time. Well, we still have 12 minutes for before we
yeah.
have the 1 hour mark. So I'll
So
let you address it accordingly.
yes. So basically, this ARIMA is one as a statistical method that is called autoregressive integrated moving average.
Okay.
So if you heard the moving average, that is one of the common
Okay.
mathematical terms where we find out the moving average. So it's a forecasting model that has auto-regressive integrated. So it combination of auto-regressive and the moving average uh, that
Okay.
is called ARIMA. And the another one is the exponential smoothing. So basically, the exponential smoothing is the forecast the future value by applying approximately decreasing weight to the past observation.
Okay.
Doesn't account to for trend or seasonality. So basically, how the trend is decreasing uh, based on the past it just apply and then uh, calculate.
Okay. Yeah, because I found the prediction because in my dissertation work I dealt with the common filter, and it's more dynamic, real time type stuff where you take the past data to predict the future, let's say a position of a target. So you take the past data and then you predict the future based on where it's going to be. So
Yep.
it's basically a derivative action and anticipatory. So thank you for answering that. And LevGen also thank you for answering all the questions and for this webinar. So thank you, LevGen. I don't have any further questions. I'll take a look at the chat one more time. And I assume that there's no interest in getting PDH, so we can end this webinar early, Daily, if you want.
Yes, so Uday had a question when we started
Okay,
this.
let me see.
So let's see if he still has some question or all the
I'll mute
question,
everybody.
yeah, covered.
Okay. I have a mute all, but I don't have an unmute everyone button.
Hmm.
So I'm pressing on it, but okay, there's Thomas Wicklin and Levgen and Uday.
Hi everyone, do you hear me well?
Yeah,
Yes,
hello.
yes. Thank you a lot. This is Evgen speaking. Very informative webinar. I'm interested right now in this forecasting modeling for the business. I do a lot of e-commerce stuff, and that's why I'm came here. And I know in general what neural networks are, how does it work, and so on. And that was really interesting to hear your experience, personal experience, in applying all those methods to the business and to the real life. Thank you a lot.
So for information, I'm working I worked for the couple of ERP system and found a gap that need to be filled by some So when we launch a new product, when company launch a new product, the available ERP models or the forecasting model doesn't predict very accurate forecast, and companies are really struggling. So I'm really working on a hybrid approach where we can have a model to train specifically the new product launch. Uh, and This is when I spoke couple of I I launched a survey industry wide and collected some data that how happy they are with their current model with means if they are dealing with the new product launch, how happy their business users with using this forecasting tool. And I got a significant response. Um, this is one a gray area where I think the hybrid models can be a hybrid and dynamic model. So what that means when based on the industry, the models can be selected and then that can be trained with the data or the uh, if we don't have that type of data, then substitute data from other companies can be used to train the model. Uh,
From your perspective, what size of company can benefit from this forecasting model? Because I believe for small business, it will be overkill and doesn't bring any value. And yeah, I just want to hear your personal experience.
yeah, these companies I've seen where the uh, means mostly I work for the larger size company where
Okay.
they have a more than for example the Boeing they have a more than 5 millions of part
Mm-hmm.
and they have a four distribution center across the world. So they really need some automated tool where they lose the visibility of their inventory. Uh, how much they have a stock available and how much they stock out. So that kind of company and medium size also can go with that company. So I don't have a specific number like size, but it depends on how much inventory do you have and uh, how accurate uh, and how volatile market it is where we are operating. So otherwise, if it's a very small industry that can be done on a Excel as well. Excel has a regression analysis tool where we can have a R square as a coefficient. We can use the regression method to train like generate the forecast also.
Okay, thank you. And what about like warehouses and 3PL companies who is, providing logistics for others? How do you think that makes sense to apply these methods for them too? Or like, for example, like a service, I don't know, or it makes sense to talk about these methods only for companies who manage their supply themselves?
So it's a warehousing company. So warehousing company, I know one use case for transportation management.
Mhm.
Warehousing company. So I I can't recall any example use case for the warehousing company, but transportation planning also can be done through
Mhm.
this, like to identify the best route between the for shipping a product or material via air via sea or train, bus, or through through mm, through aircraft. So the for the transportation planning companies are using this, and they actually it can be used for the warehousing also. Just we need to
Mhm.
define the hierarchy and level to configure the model or yeah.
Okay.
Yeah.
Thank you for your time and for replies. Very interesting.
Thank you. Thank you for listening me.
Dilip, I don't see any more questions, but can you address the other acronyms that you mentioned earlier? That was in one slide. There was a lot of acronyms that you had early.
Okay. One second. Yeah, let me open this. So those are like basically the models.
Yeah.
Different.
It occurred earlier.
Yeah.
Outlining and
XGBoost and LSTM.
yeah.
So the let me. So 1 second. I'm just opening my. So XGBoost is the gradient boost algorithm. And the LSTM network is the it's a recurrent neural network model that learning long term. I don't capture the full form for this LSTM, but it's basically a neural network model. And then I can share the slides if you guys want.
Yes. Yeah, I'll post them in the 2025 Education Week webpage, in addition to the one that Manny did on Monday. And we're also going to have another AI-assisted program called the Industrial Content Platform. This is scheduled for the 2nd of May, in which Dilip, you'll be hosting, correct?
Yes.
Can you give a little brief explanation of, you've been working with Josh and the team, and I think you got 135 reviewers at that time, and now you're prioritizing these reviewers.
Yes. So, yes, thanks, John, for reminding me. So ICP is one of the platform where we publish where when the paper come for review, that platform can be used to review the all the research papers. And so the website work is right now work in progress, but we need some the consultant who is working, they need a feedback on that tools and then the papers, so that can be effectively um, created and useful for the IEEE community and society. So that basically they are going to talk about what are their expectation, how we can engage the volunteers
Industry,
to
yeah.
industry volunteers, specifically industry people who has an industry background, and that they can review the papers and provide some feedback, and
Yeah.
the website all and
Yeah.
provide the feedback.
Yeah, sorry, but in addition, you can input, basically your input would, let's say, be a paper PDF or a YouTube URL that you may find somewhere on YouTube. And then what its output would be just like a one-page summary video is, but it doesn't produce more equations. It lessens it so that it's more digestible for the customer who are industry. So they don't have to dig deep too much into the academic heavy deep research, but answers the so what is this used for, and that's what it does, and it provides references to IEEE standards and all that. I've been using it for just tutorials on STEM, because I'm interested in the STEM and STEAM outreach to make it more palatable for the K through 12 folks and students. And so hopefully, if ICP becomes successful, they might derive another platform that's more tailored for STEAM and STEM applications. Sorry, Dilip, you can proceed now.
Yeah, I think so. That's it. You cover everything. So
Okay. All right. I think we're ready. If there's no other questions, I'm going to check the chat one more time. And I don't see any other questions. So Dalip, I just want to thank the participants, Levjen and Uday, for their participation, and the other 4 people who had to leave early. So thank you, Dalip. And Dalip, as people sign off, let's just hang around for a while
Sure.
and then talk, because I wanted to talk to the other folks to see if they had trouble down. We had 40 people sign up. So I don't know if there was an email glitch, but the folks that are attending here at the moment seems to find it based on the email. And I had one person added on since I briefly looked at my email just during your presentation, and that gentleman said that they did not receive it, and so I sent it again, and then he signed up right away.
Okay.
So just I'll let you know. We still
Okay.
have left Jen on the line, and basically, Delip, that's what I wanted to talk to you about. Is just don't know what happened.
Okay.
But 40 people did sign up, and I was surprised. I expecting like 15 or 20 people,
Yeah.
based on my
Seems,
experience.
yeah. Seems to be something
Yeah.
happened. Like.
Yeah. So what I'll do is I think I wasn't I pressed the record button a little late, but so they probably missed the beginning a little bit, but I think I did some recording as a backup, like using Camtasia or something, and I'll try to have to edit it so it can be more coherent when it's delivered. It's probably going to be posted on YouTube,
Okay.
just to do the missing parts that was in WebEx. Does that make
Okay.
sense?
Yes, John.
Okay. All right.
Yeah.
And I'll post your bio as well in there, and the way we advertised your presentation on LinkedIn will also be posted at the
Sure.
2025 Education Week. Do you have any
Sure.
questions for me?
No, John. How's the presentation?
Yeah, it was good. I mean, most of them was over my head, but I understand the basics of getting past
Yeah.
data, getting historical data, so you can estimate. Because like a derivative is basically a forecasting method too.
Yeah.
You-
Actually, I deep dive in the methods, what
Yeah,
actually we are using to instead of that's why I just ask like how I wanted to set a tone based on the audience,
yeah.
and I got only one response that he's a developer, so I just went in the developer mode, and
What you
then
could do once you get Camtasia, because I'm going to recommend David that you get one, so
okay,
you can do tutorials on what you just talked about.
okay,
Does that make sense? So like make
yes,
it short, 10 minutes, like for ARIMA, 10 minutes for ANN, 10
yeah,
minutes for the neural networks base, 5 or
yes,
10 minutes, nice, short and sweet.
sure,
Uh, and then we can use that as a contribution to our STEM grants. Oh, there's something about the STEM grants I need to mention it to you. We're the only section that submitted one.
oh, okay,
And there was like 415 that was submitted. Most of them
and
came from Asia. So what that tells me that we can submit grants, because I think Region 10 got 3 or 4. Okay. And so since the other sections in the region did not submit one, or there's maybe 1 or 2, so total of 3, we can write grants based on what we need. Like we can purchase more STEM demos, purchase more STEM kits, purchase more Camtasia licenses for other people if they're interested in using, and we're going to provide Camtasia tutorials, or I can refer them to watch Camtasia tutorials, and we can just do them a demo online once they watch those tutorials.
nice idea, yeah,
Yeah. So So I don't know what happened. I was expecting about 15 to 20 people.
Yeah.
And then, right, what happened? And then I saw the email by one gentleman. He said, I didn't receive the email. And I go, I'll send it again. I sent it again. Then he signed it up again.
Okay.
But the other 4 people were able to get in, or 5 people were able to get in. And so I
Yeah.
assumed they got the email. So I guess the guy just didn't want to look for the email. So
Yeah.
so I just sent it.
Actually, we need to market it with instead of fast fashion AI models, AI and ML
Yeah,
models, because now people are the AI and ML is more catchy word than the fast fashion. So it seems to be that I cover more deeper AI ML model than money, but
yeah.
if you see the attendance is for money session was more than mine.
Yeah,
Uh,
well, he had 55, which is not too far from you, of
yeah,
40. But
yeah, but we advertise his
yeah, yeah.
session as a AI ML model. Actually, I did mistake. I need to put some AI ML wording to.
Okay. All right.
Because now AI ML is the catchy word or the trending things which people
Yeah.
attract.
Yeah.
They
So
find that
next
it's
time, we can do that, or you can do a follow-up mini session and we can
yeah, I
post that
can.
in the website, and that will attract more to the fashion stuff. So you can, like, once you get Camtasia, is to just do a mini session on AIML.
Okay.
You probably can explain it in 20 minutes, like a TED
Correct.
Talk.
Yeah.
Okay. And you know what TED Talks are, right?
Yeah. Yeah.
Okay. So you can practice and delivering a TED Talk.
Yeah.
Okay.
Sure. Sure.
And then we can go from there.
Okay.
Okay. I hope you're
Sounds
pleased
good.
with the session and how we market it. It's just next time we'll do it with AIML, if
Yeah.
that's
Lesson learned.
or we can provide just a tutorial on
Yeah.
AIML and see how much interest there is in getting a tutorial. Have you
Yeah.
seen the YouTube videos that provided that?
Yes.
Those type of things, are they good enough?
Yes. Yeah. They're good, John.
Yeah. The
Yeah.
one I posted in the Steam Team notes, there's one guy who posted LLMs, and let me see if I can find that. I think it's on the 21 April. Let me see, 12 May. Yeah. Go look in the Steam Teams notes. Do you know how to navigate there, Dailip?
Yeah.
Okay. And one of the comments says this is the best. So I'll take a look at that and tell me what you think. The first video. There's about a series of 8 videos.
Okay.
Okay. And then yeah. Okay. But are you happy with the presentation and the bio, how it was presented?
Yeah. Yeah. It's really good.
Okay. The
Yeah.
one I couldn't correct is that when I was editing the word dilute, it kept
Yeah.
reverting to the back. So it doesn't catch, those are the errors that AI can't dilute. Like, for example, I have to spell the word IEEE, not IEEE. Otherwise, that's what they would say.
Yeah.
But they spelled your name 4 different ways.
Yeah. Actually, it's Dilip, but
Oh, Dilip.
somehow Dilip and
Okay.
somehow AI put Dilip, something like this.
Yeah, yeah. So,
Yeah.
so I couldn't
So,
edit at my end, or I tried to, and
yeah,
then I
but
saved
it's
it.
fine.
But
Yeah.
I put your real name on top of the video just to make sure
Yes. Yes.
people are aware of it. And then if anybody says, "How come your name is not spelled correctly?" I said, "That's AI.
Mhm.
It's not perfect."
Yeah.
Okay.
Agree.
All right. Well, anyway, thanks for doing the presentation and for hosting Manny, and you'll be hosting the one with Rob Fish. I'll be there too, just in
Okay.
case, and I'll do a little bit of intro, and then you can moderate the rest.
And John, one more thing. This one email yesterday came for the RAM. He
Oh,
was
yeah, yeah.
he
I
was
saw that one. What do you think?
so he has similar background what and he attended what session. So are we able to accommodate him on any of the session, or he's
No, we
interested
can
in
just
presenting?
generate we can generate a presentation and do the same thing what we did with you and Manny. It doesn't
Okay,
have to be this week. It can
okay,
be either the second, third week, and even May.
okay,
You know,
okay.
just
So
let them know, and pick it. And I'm kind of busy in May, but yeah, the early part of May, maybe the third or fourth week of May would be better for me.
okay, sure. Then yeah. So
And he gets more time to prepare, and you get more time to review his work by asking him, hey, I like to review your slides to make sure it doesn't duplicate
sure.
our other 2 sessions. So you can use that as a method for review, because he said we gave 2 similar sessions, and then you can point him to the 2025 Education Week website page.
Okay.
If
Okay.
he needs to review and needs to modify his presentation so it doesn't seems to be repetitive.
Okay. Sure.
Does that make
Sure.
sense?
Yes, John.
Okay. All right.
Okay.
We'll talk later.
Sure, John. Thank you so much.
Yeah, thank you.
Thank
Okay.
you. Bye.
Bye-bye.
Bye.